With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
A sphere shown in figure lies on a rough plane when a particle of mass small m traveling at the speed v0 collides and sticks with it. If the line of motion of the particle is at a distance h above the plane, find a, the linear speed of the combined system just after the collision. B part, the angular speed of the system about the center of the sphere just after the collision. And C, the value of h for which the sphere starts pure rolling on the plane. Assuming that the mass capital M of the sphere is large compared to the mass of particle, so that the center of mass of the combined system is not appreciably shifted from the center of mass. So the combined system consists of sphere and the particle. Since no force is applied on the combined system, the linear momentum is conserved. So for A part, you can say that linear momentum is conserved. This implies momentum initial is equal to momentum final. The initial momentum is m into v0 and the final momentum is the total mass of the system, that is capital M plus small m into v. This implies v is equal to mv0 upon capital M plus small m. This is the linear speed after collision. For the B part as well, there is conservation of angular momentum about the center of mass because no torque is applied to the combined system. Therefore, you can say that angular momentum is conserved, or you can say angular moment about center of mass is conserved. So initial angular momentum is equal to final angular momentum. The initial angular momentum is equal to small m, its velocity v0, into the perpendicular distance from the center of mass, which is equal to h minus r. So this is the velocity component line, and this is the value of the perpendicular distance small r. So this is equal to h minus capital R. And the final angular momentum is equal to the moment of inertia of the whole system, which is 2 by 5 capital M capital R square plus m into capital R square into omega. This is due to the mass small m sticking to the periphery of the sphere. This implies m v0 h minus capital R is equal to 2 by 5 m plus small m into r square omega. This implies we get omega is equal to m v0 h minus capital R divided by 2 by 5 m plus small m into r square. This is the angular velocity of the combined system after collision. In the C part, the question asks the value of h for which after collision there is pure rolling. So in case of pure rolling, the velocity of center of mass is equal to the angular velocity omega into the radius capital R. This implies putting the value of v that we calculated in the A part, we get m into v0 upon capital M plus small m is equal to omega we found out to be m into v0 into h minus r divided by 2 by 5 capital M plus small m into r square into r. 1 r will be divided. So we get h is equal to 7 upon 5 capital M plus 2 into small m divided by capital M plus small m into r. This implies h is equal to 7 by 5 into capital R. This is the value of h, for which after collision the sphere undergoes pure rolling. We got this relation assuming that the mass capital M is very greater than small m. So these terms would get neglected and the m terms would be divided. So we are left with 7 by 5 in the bracket.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.